Well, hi everyone. Go through some of these practice problems for our quarter 4 exam and rewrite 2 to the 9th equals 512 in logarithmic form. Alright, what's going to be log and base 2 of 512 is equal to 9. Remember the base here, what you're taking the log of. The answer to a logarithm is the exponent. Alright, now we go the other direction here. 3 is the base. The exponent is that answer there, equals 81. Now, number 3, it says approximate log of 157 rounded to 3 decimal places. And that's log. It's log base 10 of 157. I'm seeing 2.196. Okay. Number 4, rewrite natural log of 25 over 4 in terms of natural log of 4, natural log of 5. So I'm looking at natural log of 25 over 4 would be the natural log of 25 minus the natural log of 4. Natural log of 25, that's natural log of 5 squared minus natural log of 4. Remember the quotient property, we split it up with subtraction. And then the power property here, I can put that 2 in front, so that's 2 times the natural log of 5 minus the natural log of 4. So now we are in terms of natural log of 5 and natural log of 4. Now number 5, we want to expand this. And I see products here. So the product property, that's log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y, and I'll rewrite this middle one so that I have log base 4 of 5 plus 3 times the log base 4 of x plus the log base 4 of y. This is the power property there. Now on this one, I'm going to take the natural log of the square root of 3x minus 5 minus the natural log of 7. And this is the natural log of 3x minus 5 to the half power minus the natural log of 7. I'll put that in front with the power property and have 1/2 times the natural log of 3x minus 5 minus the natural log of 7. And now we want to condense, and that's minus, well, first of all, I'm going to put this here and make this the natural log of x plus 2 squared. Then minus the natural log of x, and now I'm going to use in reverse, kind of use the quotient property and write the natural log of x plus 2 squared over x to make it into one logarithm, so we have condensed it. Well, this 1/3, I think I'm going to put it up here first. No, actually, log base 2, I'm gonna condense inside first. Change my mind. Now I'm allowed. Log base 2 of x over x minus 4. And that would be log base 2 of x over x minus 4 to the 1/3 property. I think I'll write it with a radical. I'd be okay with this answer though. Just looks better. All right. Now, this next one, we're going to use the change of base. And log base 5 of 57. I'm going to use base 10 first. That's the log of 57 divided by the log of 5. I'm going to use base 10 logs. And if you take log of 57 and divide that by the log of 5, you get 2.512. And if I take the natural log of 57 over the natural log of 5, there's natural log of 57 divided by natural log of 5. I was using that button for natural log. I get the same thing. Okay. And this actually, I think, I haven't used it in a while. The log base, and put the 5 here and the 57 here, kind of makes the change of base a little obsolete. All right, some equations to solve. I'm going to divide by 4 and get e to the x power equals 91 divided by 4, 22.75. And I'm going to take the natural log of e to the power of x, and I'm going to take the natural log of 22.75, because if I take the natural log of e to the power of x, those are inverse operations, and that solves for x. And now all I have to do is take the natural log of 22.75, 3.125. X is approximately 3.125. Number 9, I'm going to subtract 8 from both sides. And I've got 5 to the power of x equals 18. And what I want to do now is take the log base 5 of 5 to the power of x, and I'm going to take the log base 5 of 18. Those are inverse operations. So that is x, which is approximately, I'm going to use the log base. You can use the change of base if you have to. Like we did on number 7, you can use the change of base formula to figure out what this is if you don't have that capacity on your calculator. There's 5, there's 18, 1.796. All right. Next equation, number 10 here. I'm going to divide by 4. And I have log of x minus 6 is equal to 11/4. Now, I'm going to rewrite this. This is, I think, what you guys were telling me was your preferred method, and write 10 to the power of 11/4 equals x minus 6. The base is 10 here. There's the exponent, and it equals that. I'm going to add 6 to both sides, and I could have done that number earlier, but 10 to the power of 11/4, hit that arrow, plus 6, I'm getting 568.341. 4 times the log of, oh, I got it right here, 568.341 minus 6. I'm just checking my answer right now and seeing if we're close to 11. We are really close to 11 there. Okay. All right, number 11. I'm going to use the product rule here and take the log base 2 of x times x plus 2 equals log base 2 of x plus 6, which is the log base 2 of x squared plus 2x, and the log base 2 of x plus 6. And now we got 1 to 1 we can use and say x squared plus 2x is equal to x plus 6. And I'm going to subtract x and 6 from both sides. And I got x squared, 2x minus x is x, minus 6 is equal to 0. That factors pretty nicely. I think if I go plus 3 and minus 2, so x plus 3 is 0, which means x is negative 3, or x minus 2 equals 0, which means x is 2. And one more thing, I can't take the, if I check this one, I can't take the log of negative 3. Can't take the log of a negative number. If you don't remember and you're thinking, okay, let me look. Oops, non-real answer. All right, so this one's extraneous, and this is our answer. So that needs to be checked. Number 12, the first 5 terms of this sequence, 3n cubed minus 5. So a1, that's 3 times 1 cubed minus 5. A2 is 3 times 2 cubed minus 5. A3 is 3 times 3 cubed minus 5. A4 is 3 times 4 cubed minus 5. And A5 is 3 times 5 cubed minus 5. And that's 3 times 1, 1 to the third is 1, minus 5. So I've got negative 2. 3 times 8, 24, minus 5 is 19. 3 times 27, that's 81 minus 5, that's 76. 4 to the third power is 64. 192 minus 5 is 187. 3 times 125, that's 375, minus 5 is 370. So that's what I've just got from my calculations. Okay, it says write an apparent expression for the nth term. All right, it's plus 2, plus 6, plus 10, plus 14. Looks like the amount we're increasing is going up 4 each time. So this is an n squared. It's a quadratic. If you're going up the same amount, like the second difference, and we didn't practice this, so this is not part of what we're going to be doing. Okay. And if I square 1, so 1 squared, you get 7. 2 squared, no, 5. 2 squared, 7. 3 squared, 13. 3 squared plus 4, 2 squared plus 3, 1 squared plus 4,